Okay, let's start this content off with a bit of a callback. The Cartesian plane is a grid with two axes. The x-axis goes along left and right horizontally. The y-axis is vertical. So the points with coordinates x and y can be plotted on a Cartesian plane. If I've got a quadratic equation that has x and I make it equal y, then you've got a clearly stated relationship between the variables x and y. Before we do that, can you guys help me? Tell me the coordinates of that red dot. Let's see if the red dot, 3, 1. Well done, good. What are the coordinates of the blue one?
-3, -2.
Good, okay. So again, you proved to me that you may actually be quite good because last year I had all forms of different stuff. You seemed very solid knowing that you have to say the x first. How far left and right it is first. And then second is how far up and down it is. So how does this relate to quadratics? Well, if I've got a quadratic equation that looks like this, x squared plus 2x plus 1, and I'm making it equal y, what does that actually tell you? It tells you that y is always whatever x is squared, that's what this is, plus 2 lots of x, plus what? What's the end bit say? 1. So whatever the y coordinate is, it is going to be x squared plus 2x plus 1. So that gives us an easy way to graph any quadratic. I just need to go put any x in that I want, find y, and that gives me a pair of x and y. So the way you do this is called a table of values. So this is where your notes would start, and I'll give you time to get that down. A table of values is simply a table with 2 rows. The top row is for different values of x. The bottom row is for different values of y. You fill in the table by substituting x one by one into the equation to find the matching y. Once you've filled it, can you imagine a bunch of, 2, 3, 3, 4, 4, 5. I can trace that line. I can just put dots all over that Cartesian plane and trace it. So this is your backup plan. You have one question. I think it's worth about 5 marks to graph a quadratic using this. Please don't lose marks from that because you're just doing dot to dot. Okay? The second lesson today is a more algebra involved way of drawing quadratics. If you can't do that, but you can still draw the quadratic using a table of values, you'll get marks. Okay? Use this as your backup. So if you, a minute or so, can you get that info down and then we'll demonstrate it. And I'll get you to practice that for 30 minutes. And then we'll do Mr. T's Diva method. Okay, let's demo that. Use the table of values below to graph y is equal to x squared plus 2x plus 1. At your year level, you're going to be told what x is. Okay? Hopefully you're seeing potentially, if these weren't selected properly, you wouldn't see a nice graph. You'd see a tiny portion of it. Okay? For year 10 level, you're going to be given this. And your exercise book, you're told what x's are on, okay? So what does these instructions mean in context of a question? Use the table of values below to graph y is equal to x squared plus 2x plus 1. What do? I substitute all of those different x's into the equation one by one. So what's my first x on the left? Negative 2. So what does the equation look like? Y, when x is negative 2, that's just to remind myself, it's negative 2 squared plus 2 lots of negative 2 plus 1. It is important that I put it in brackets, because if I didn't put that in brackets and I had just negative 2 squared, that would make me square 2, which is 4, and then I'd put a negative in front of it, which is negative 4. That's different to this, because if there's brackets around it, what does that mean? I'm timesing negative 2 by itself. What's a negative times by a negative? Positive. See, that's completely different. So please use brackets. Now let's solve for that. Negative 2 squared is 4. What's positive 2 times by negative 2? Negative 4. And there's a plus 1 on the end there. So 4 take 4 is nothing. Add 1, 1. That's my first dot. So someone tell me, I've got my little laser pointed in the origin. If I want to plot negative 2, 1, where do I go from here? What direction do I go? To go negative 2, 1. Left, how many?
2.
And how far up or down? Up 1. So that's going to be my first. That's going to be my first dot there. That's not enough to draw anything. That's not even enough to draw a straight line, because I don't know what direction it goes. So how do I go about working out how to draw this quadratic? Do I have a bunch of other x's to do? Okay, we'll take it one at a time. You tell me what to write for my working out for what, when x is equal to negative 1. What would I write for the working out?
Negative 1 in brackets squared.
Yep.
Plus 2, negative 1 in bracket plus 1.
Okay. Negative 1 squared. 2 times by negative 1. Plus 1. 1 take 2 is negative 1 plus 1. So what's that going to be? 0. Negative 1, 0. I can do another dot here. My laser is in the origin. Where do I go? One step to the left. Do I go up or down at all? No. I've got another dot. Right now, these two dots would allow me to draw a straight line. That's not what a quadratic is. So y for 0. Now can you tell me what my working out would be?
0 in brackets squared plus 2 in brackets 0 plus 1.
0 squared is nothing. 2 times by nothing is nothing. You've got 1 there. So 0, 1. Put a dot here. Now we're getting somewhere, because what a quadratic is parabolic. A parabola is like that. Okay? It goes up, then goes down, or it goes down and then goes up again. Okay? It's smooth and it's symmetrical. Can you see that that's already symmetrical? It's going down and then going up again. But we're not done, because I've only traced the tip of it. So someone else, next working out.
1 squared plus 2 times 1.
Plus 1. 1 squared is plus. What's that?
4.
So I go across 1, up 4. So it's reaching up. Last one. You with your mouth open. Y for when it's 2.
2 in brackets squared plus 2 times 1. 2, sorry.
2
plus
times.
1. Sorry.
That's all right. 2 times 2 squared. 4 plus.
4,
Plus.
1.
What do we got? 2 and 9. So now I have 2 here, 9 up there. It looks like we only have 5 dots. It looks like, yes, we only have 5 dots. But because a quadratic is symmetrical, can we put a couple of other dots there as well? Where could we put those other dots? You, nodding your head, you tell me where to place those other dots if I'm starting at the origin. How far would I go up? -3, good, I like that. And then? Up to 4. What's she doing there? She sees this, and that should be the same on the other side. Why? Because a quadratic is symmetrical. Someone else? One more. I'm at the origin. Where do I go to match the highest dot? Oh, cat got your tongue.
-4, 9.
Yes. Well, no. Why is that useful? It helps me trace it. Okay? I am not going to be marking you based on how perfectly, smoothly curved, how thick that quadratic is. I just want it to go through the dots and be curved. Okay? This is an iPad. This screen is very smooth, so I'm going to try my best. But as long as I see that you're attempting to make it, see, that's too V-shaped at the bottom. We want it to be curved, so I'm going to try again. Okay? You want it to be done in like one motion. So, okay, I'm happy with that. It's kind of curved. And then curve it up. I want to mark you down for. Okay? What am I going to mark you down for? I'll mark you down for straight, 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 straight. If you dot to dot it, that's not what a quadratic is, because quadratic is smooth. Okay? Also, if it's too V-shaped, I'll mark you down. Okay? But if I can see that you've tried to make it curved, and it's curved all the way through, and it pretty much goes through those dots, you'll get full marks. Okay? That is how you will use a table of values to draw a quadratic. Okay? So, basically now, for 30 minutes, I would like you to work on 18B1, 1 ACE 2. You are not doing exercise 18A on the timeline. So can you make a start?